Part 8, we trained a transformer on trillions of tokens of text. Next token prediction, millions of batches, thousands of GPU chips. The result is a language model. It generates fluent text, but it doesn't follow instructions. Type a question, and it might continue the question instead of answering it. 3 steps turn a base model into an assistant. Here's what a base language model actually does. You type, "What is the capital of France?" The model sees that as the start of a document. Its job is to predict what comes next. So it might continue with, "What is the capital of Germany?" "What is the capital of Spain?" It's generating plausible next tokens. A quiz document has more questions. That's a reasonable continuation. What you want is an answer. The capital of France is Paris. But the model was trained on raw text from the internet. It saw articles, forum posts, textbooks, code. It learned to mimic all of that, not to respond helpfully to a user. To get from completion to conversation, you need to change the model's behavior after pre-training. The first step is supervised fine-tuning. You create a data set of examples that look like conversations. A user asks a question, and a high-quality answer follows. Thousands of these pairs written by human annotators. What causes rain? Followed by a clear, accurate explanation. Write a poem about winter, followed by an actual poem. Each example shows the model what a good response looks like. You take the pre-trained language model and train it on this data set. Same process as before. Forward pass, compute loss, backpropagate, update weights. But now the training data isn't random web text. It's curated instruction response pairs. After a few thousand examples, the model starts to get it. Ask a question, it gives an answer. Give an instruction, it follows it. The format clicks. Supervised fine-tuning doesn't teach the model new knowledge. The facts were already in there from pre-training on trillions of tokens. What it teaches is behavior, how to format a response, when to stop generating, how to stay on topic. The model already knew that Paris is the capital of France. Fine-tuning teaches it to say that when asked instead of generating more quiz questions. But there's a limit. The model can now follow instructions and give answers. Some of those answers are great. Others are mediocre. How do you tell the model which answers are better? The loss function in supervised learning just measures whether the output matches the target text. It can't capture whether a response is helpful, clear, or safe. You need a different signal. Instead of writing perfect answers, you can compare answers. Give the model a prompt. Generate 2 different responses. Show both to a human annotator and ask, which one is better? Maybe response A is accurate but dry. Response B is clear, well-structured, and includes a helpful example. The annotator picks B. You don't need to explain why, just the preference. Do this thousands of times across different prompts. You end up with a data set of comparisons. Prompt, response A, response B, and which one the human preferred. This captures something a loss function can't. Human judgment about quality, not just whether the words are correct, but whether the response is actually good. You can't ask a human to evaluate every response during training. That would be way too slow. So you train a separate model to do it, a reward model. It takes a prompt and a response as input and outputs a single number. A score. Higher means better. You train this reward model on the human preference data. For each comparison pair, the reward model should assign a higher score to the response the human preferred. After training on thousands of comparisons, it acts as a stand-in for human judgment. Not perfect, but fast enough to score millions of responses during training. Now you can improve the language model using the reward model as a guide. This is reinforcement learning from human feedback, or RLHF. The language model generates a response to a prompt. The reward model scores it. If the score is high, the model's weights shift to make that kind of response more likely. If the score is low, less likely. The optimization algorithm is called PPO, yes, Proximal Policy Optimization. It updates the model gradually so it doesn't drift too far from the fine-tuned version in any single step. There's a real risk. If you optimize too aggressively for the reward score, the model finds shortcuts. It might generate responses that score well but sound unnatural or repetitive. That's called reward hacking. PPO keeps the updates conservative to avoid it. RLHF works, but it's complicated. You need to train a separate reward model, run reinforcement learning, and carefully balance the optimization to prevent reward hacking. In 2023, researchers proposed a simpler method, direct preference optimization, or DPO. DPO skips the reward model entirely. It takes the same human preference data and directly adjusts the language model's weights to make the preferred response more likely and the rejected one less likely. One training loop instead of two, no separate reward model needed. Mathematically, it arrives at the same place as RLHF under certain assumptions. Simpler to implement, and many modern models use DPO or something close to it. There's one more piece. You don't just want a model that follows instructions well. You want one that's safe. If someone asks the model to help with something dangerous, it should decline. If a question is ambiguous, it should ask for clarification instead of guessing. If it doesn't know something, it should say so rather than making things up. This is alignment, making the model helpful, harmless, and honest. It's built into the preference data. Annotators are told to prefer responses that are accurate, that acknowledge uncertainty, and that decline harmful requests. The reward model learns these preferences too. Alignment isn't a separate step you bolt on at the end. It's woven into every stage of post-training. Here's the full path from raw model to assistant. Start with pre-training. Trillions of tokens, next token prediction, weeks of compute. That gives you a base language model. It knows language, but it just completes text. Supervised fine-tuning comes next. A few thousand curated examples teach it to answer questions, follow instructions, and hold a conversation. Then RLHF, or DPO, refines the quality using human preferences. The model learns not just to respond, but to respond well and responsibly. All the knowledge was already there from pre-training. Post-training shapes how the model uses it. That's how you go from language model to assistant. Supervised fine-tuning teaches the format. Human preference data captures quality. Reinforcement learning or direct optimization makes the model internalize those preferences. And alignment keeps it responsible. Every major assistant today goes through this pipeline. Pre-train on text, fine-tune on instructions, optimize with human feedback. But these assistants do more than answer questions now. They reason through problems step by step. They process images and audio, not just text. They use tools, browse the web, write and run code. How do you get from a chatbot that follows instructions to an AI that reasons, sees, and acts? That's part 10, the frontier.